In this video, we're going to keep looking at adding and subtracting rational expressions, but here we're going to do it in a slightly more complex fraction. What that word means is complex fractions means it's a fraction over a fraction. And we did see these the other day. We learned to think of this as just a big division problem, and dividing by a fraction, we're going to turn that into multiplying by a reciprocal. But not yet. First, and this is a very important thing to know to do first, is first, we need to simplify the numerator and the denominator on their own separately. So we're going to simplify both the numerator, which means we need to do some subtracting, and the denominator, which means we're going to need to do some adding down there, separately. They have nothing to do with each other yet. So we're going to use the same thing we did in the last video, talking about adding rational expressions. We're going to make a common denominator. I've got an x and a y in my denominators in the numerator. Notice how I don't even care about this right now. It has nothing to do with it. I'm just looking at that. So I need a y in my first fractions denominator, and I need an x in my second fractions denominator. So we will multiply to make a common denominator, multiply by 1 to make a common denominator. So we get y over xy minus x over xy. And now that we have a common denominator, we can combine those into a single fraction. Y minus x over xy. Notice how this is all still just the numerator. So I should keep writing that. And now I can go back and deal with the denominator too, which is going to work very simply. In the denominator of this complex fraction, there is one term that has a denominator and one term that does not, which means we need to put one there. So I'm going to multiply by x over x in order to have that common denominator. So the first term is x over x multiplied by 1 plus 1 over x. And now that we have common denominators, we can add the numerators together. Once we've done that, once we've simplified the numerator and the denominator separately, then we can turn it into multiplication. And this is what we saw in our last class. Dividing by a fraction is the same thing as multiplying by the denominator. So I'm going to rewrite this as y minus x over xy times the reciprocal of the denominator, x over x plus 1. And now we'll see if anything reduces or cancels out. A tiny little smidge does here. There's an x in the numerator and an x in the denominator that are factors, so they both will cancel out. Notice how, of course, this x and this x, those won't cancel out because they're not factors. They're terms in a bigger factor, so we can't cancel them out. But the x's that are their own factors will cancel out, and so we'll have y minus x over y times x plus 1. Please don't bother distributing that y or foiling in general in this denominator. Just leave everything factored out, and that is much, much better. You can leave your answer like this. As soon as we see expressions that have two constants in it, talking about domain restrictions starts getting a little bit weird. So I'll say you can leave it like this and not talk about the domain restriction anymore.